Hello everyone. In this session and the following sessions to come, we are essentially going to solve this real world problem where we are trying to identify the disease of different plants that we are having. So the dataset that we are going to consider here is plant disease dataset. So this dataset typically includes images of healthy and diseased leaves from various plant species categorized into multiple classes based on plant type and specific disease, right? So there are variety of plants that we are considering. If you are looking at this particular subfolder here, these subfolders within this root directory indicates that these are the different plants and their associated diseases here. So the file name or the directory name here is going to be the combination of plant type and the disease type here. So apple scab is a specific disease associated with apple leaves. Black rot again is specific disease associated with apple leaves and all. So likewise, we have bunch of fruits and vegetables and their associated diseases. So we're now going to create an image classifier by implementing the convolutional neural network model. Okay. So without any further ado, let's get into this particular coding exercise where we are essentially going to read the given complete data, then create a dataset and a data loader object, which is the primary aspect of data pre-processing engine here. But we are clear about the dataset, isn't it? So this basically includes images of both healthy and diseased leaves for various plant species, right? And what exactly is that we are going to do now? So we are going to create a classifier which accurately and efficiently identify the diseases. Thereby, it might help farmers or agricultural experts to make informed decisions in real time, right? Let's say that a particular farmer or an agricultural expert just takes a picture of a particular apple leaf, then tries to upload in a particular application. Then in the backend, this convolutional neural network model is going to get executed and generate predictions. It's going to typically produce the result as a type of disease that's involved with that particular leaf. If it's healthy, it's going to return healthy as the predicted label. That's the whole exercise, or that's the whole exercise that we are going to solve, or problem we are going to solve in a span of different videos in this series. Okay. As a very first step, we are now going to import all the necessary libraries and modules that are required to conduct this exercise. Okay. Once that is done, we're now connecting to Google Drive since I have placed all of my data in Google Drive. So whatever zip file I had, I have extracted them into this particular directory called plant disease dataset without augmentation. So now this is the dataset path here. So there are multiple subdirectories within this particular root folder, right? Each of these subdirectories is associated with a class label. So this here could be a particular class label. I'm associating it with 0. This here is label 1. This here is label 2, so on and so forth. That's how you need to interpret it. And within every subdirectory, you have bunch of images associated with the disease type and the plant type here. Cool. Once we have set the dataset path from where you are supposed to read the data and create a dataset object. This dataset path is going to help us create an initial dataset object here. Later, we are going to create a custom dataset class with specific definitions on how we would want to access a given sample there. Let's not worry too much about it. For those who are not aware of what dataset object and what data loader object is, please revisit one of my previous sessions where I have clearly explained the difference between dataset and data loader objects. So to set a context or background, data loader objects are basically going to help us read the data batch by batch. And within each batch, you might shuffle the data for the model training process. So you also have this ability to shuffle the data. You need not shuffle the data for validation and test sets. So the order in which the images or data is defined for test set can be as is, because there might be multiple models that you are creating and you would want to assess the evaluation by considering the different predictions that you have generated from different models, and you would want to preserve the order for test set and validation set. Shuffling the data is only required for the trained set since it induces some generalization to the model. Otherwise, the order information can actually provide some key insights to the model with which we might end up creating an overfitted model. That's the caveat there. Anyhow, by making use of this particular dataset path and image folder class, there is a specific class called image folder. If it's not there, we are now going to import the image folder class. So from torchvision datasets module, we are now going to import this image folder class. So what is the speciality of this class? Let's understand that. So before we understand what image folder is, let's create an object associated with it. The object associated here is going to be the dataset object itself. So we are essentially going to provide the root directory, which is a dataset path that I have defined in the previous step. Along with this, I'm also going to provide additional information, which is transform information. So I'm going to apply some transformation to the existing image data. I just wanted to convert all of my images into tensor objects. That's the only transformation that I'm currently looking at. So transforms.compose is going to help me actually transform all of the given image data into tensor objects by using this particular method called toTensor, right? So once this is created, so once we have created this transform object, I can simply make use of this transform object as one of the arguments that I can pass while creating the dataset object. That's all. So image folder is now necessarily helping us to read the data which is preserved as per the structured path that we already have here. So this image folder is going to help us read all of the structured data and then eventually create this dataset object for us. If the data is not arranged as per the structure that's given here, if the data is not arranged as per the labels information related to each of these subdirectories, then we might not want to use image folder, but we might want to use the generic dataset class in order to create the dataset objects. Please keep that in mind. So once we have created this dataset object, we can simply look at the contents of it. That is the attributes and methods associated with this dataset object. We have various attributes and methods. So there are specific attributes like underscore alien underscore and underscore get item underscore double underscore get item double underscore. So these are two different methods which we are going to override in the custom dataset class because we want to redefine the way in which we need to retrieve a particular sample from the given dataset. If you want to redefine the way in which you need to read the sample, then probably you might need to create a custom dataset class. Otherwise, you need not. Okay. I want to redefine the way in which I am reading a sample, a particular sample from my dataset, and then I would create a custom dataset class for that. So before I do that, I also would want to inspect some of these attributes. So some of these attributes like samples. So dataset.samples is going to help me retrieve all the samples information. So this here is going to be list of tuples. Each tuple holds two different elements. So one of which is going to be path of that particular image and the associated label. I did mention to you that every subdirectory is associated with a particular label. So this is the information that we can make use of. And we also have other information or other attributes like targets, which is going to help us provide the list of targets that we are having, which is nothing but the labels for all of the images that we are having. And we also can look at classes. So classes is going to give us the names of these classes. Names of these classes as in the names of these subdirectories here. There is another attribute called as class to index, which is going to provide us a mapping of these labels for different class names that we are having. So these are the mappings. So this is a dictionary here. So each class name is now associated with a individual class label, as we can observe here. So obviously I'm not going to consider all of this data for creating a CNN model. Since it is computationally very intensive, I'm going to restrict myself in considering a couple of plant varieties, one of which is apple and the other one is potato. I'm connected to T4 GPU here. Unless I'm connected to a powerful GPU, I am going to make use of only filtered data here. So if I'm connected to a powerful NVIDIA GPU, then probably you can look at exploring adding more of these classes to your data, right? Or adding more number of samples here. So now I am going to filter this given data. So what am I going to do now? I am going to filter the data to include only apple and potato samples. Cool. So before I do this, let me actually print the dir information of the dataset. So we do not have this long list of attributes and methods here. Cool. So in order to filter this particular dataset, I am now going to create two different empty lists. So one of which here is going to be new classes. So new classes, and One of which is going to be new classes and new samples, right? Because we are now going to define samples and the classes associated with these different samples here. So for path comma label in the different samples that we can access from dataset object, I'm now going to inspect which of these path does have apples. I'm just converting this to lowercase so that I need not actually stick to this particular convention. I can also check if potato is present in this path in label.lower. If either of these is present, then what am I going to do? I am going to consider this path and label and simply append this path and label information to my empty list, which is going to be new samples here. That's all. And if any of these labels that we are reading across all of the samples within your dataset, I am now also going to investigate the different classes associated with it or class names associated with it. Sorry about the typo here. It should be if not for, right? So here I am going to inspect the classes associated with these different labels that I have read or these different samples that I have read, right? Sorry about that. If dataset.classes and within subscript I'm providing label. So what exactly is dataset.classes? Let's inspect that first. So dataset.classes is going to return you all the names of different subdirectories or classes information to you. So now, since we are only restricting or filtering these data like apple and potato data, right? We are now including this particular block of code within this if condition. Only when this condition is satisfied, only when the path here, not the label, right? Only when the path that we have read for different samples within the dataset does have apple and potato, then only you are now going to consider the class names associated with them. And if those class names are not available, if they are not available in the new classes that I have defined earlier, the new classes here is going to be an empty list again. I'm going to append this information to the new classes. That's all. Nothing apart from that. Whatever information that I'm retrieving, whatever class information that I'm retrieving, I'm now going to append it to the new classes empty list that I have defined previously. I can simply inspect what new classes would contain. New classes would only contain apple and potato information. That's what we wanted. And new samples also does contain only apple and potato information. You can simply go about validating the different labels associated with this particular data. For path comma label in new samples, you can only retrieve label and then associate this with labels and finally look at getting the frequency distribution of it. I can make use of counter function from collections module. Use this counter function within parentheses. I'm providing labels here so as to derive the frequency distribution of different labels. I clearly can understand that we now have only 7 different labels. 3 of them or 4 of them are related to apple and 3 of them are related to potato here. So 21, 22 and 23 are the different labels associated with potato. But I would want to update this label information. So these 21, 22 and 23 are the index positions that were available in our original data, not the filtered data. I need to update this new samples data in order to change these index values or change these label names. Okay, how do I do that? So before I do that, let's actually create class to index information or class to index dictionary here. So you earlier have observed that we had this particular attribute called class to index, which has these different combinations of the plant and disease combinations as well as the labels associated with it, right? I would want to create an equivalent class to index attribute associated with my new samples data. So how do I do that? I simply can write a simple dictionary comprehension where I am reading both class and index, right? I'm reading both class and index. For index comma class in enumerate the different new classes that I have defined in my previous step. That's all. So now you have these combinations of classes and indices that you would plan to have within your filtered data. These are the indices that I now need to update in my actual new samples data. So how do I do that? I simply can make use of this particular information, which I'm calling it as new class to index. I can make use of this particular dictionary for whatever labels that I'm reading for path, comma label in new samples for whatever information that I'm reading from the new samples. For whatever information that I'm reading from the new samples, I can always go about, there's some problem here. So we need to have these parentheses, otherwise we'll get an error like what you're observing currently. Okay. So we can make use of this label information here and use this new samples to index dictionary that we have created, right? And within parentheses, I am now going to actually look at having this particular information like dataset.classes and whatever label that I'm having, whatever label that I'm reading from new samples. So this information is going to provide me the right label value that you are currently observing. If you look at this, so label here, probably I'm providing it as 6 or probably 21, right? Sorry about that. 21. Now you are getting a value of 4 because 21 was associated with potato early blight in our original data. Original data points to dataset object that we already have defined. I'm just copying this whole statement, replacing it here. Instead of 21, I'm just providing label and reassign this whole thing to new samples, right? Reassign this whole thing to new samples. And that's it. So your new samples will now have the latest updated indices or latest updated labels. You can simply rerun this code in order to understand if now we are observing these latest labels or not. That is 4, 5, and 6 instead of 21, 22, and 23 that we have observed earlier. So we now have updated this information and we are good to go. So with whatever new samples that we have defined now, we are now going to create a custom dataset class. Our custom dataset class should only be related to new samples. That is a filtered data and not the complete data. And I also mentioned that custom dataset class is going to help us define the way in which we need to retrieve a particular sample from the data. So we are going to do method overriding for underscore alien underscore double underscore alien double underscore and double underscore get item double underscore. Cool. So let me define this new class called probably custom dataset. And I'm going to inherit all the methods and attributes associated with my parent class called dataset here. Okay. So once this is done, I'm going to define the constructor, which is init method, which actually has or which actually holds these different parameters that I'm now defining, which is samples, class to index, probably transform. So what am I trying to do here? I am just trying to define all the different attributes that we have looked at earlier with respect to your dataset object. So with respect to your dataset object, we have looked at various attributes like targets, classes, class to index, dictionary. We also have looked at dot samples, all of that, right? So we are going to simulate the same for our custom dataset class. That's all. So self dot samples will hold samples itself. I'm also going to create self dot targets. Though I have not provided it as a parameter, I can simply go about creating it by making use of the samples information that I already have. So I can find the label by iterating over these samples for path comma label in samples. I'm just reading only label here. That's all. So now you have the target information available to you just by making use of samples here. Cool. So once that's done, you can also define class to index. We already have received that as a parameter, so we can assign it directly. After that, you can also assign this list of different keys of this particular dictionary, which are nothing but the classes itself, to self.classes. So we are extracting the keys of this particular dictionary that we are passing as an argument while creating this particular object of this class. We simply take the keys of it, convert into a list and assign it to self.classes. And finally, we'll also assign transform to self.transform if there is any transformation that we are planning to conduct for the given dataset. And we'll also do this method overriding for alien method, as well as we'll also do it for get item method, as I have mentioned to you earlier. So both of these methods have got self within the parenthesis. This additionally has got an index. So len method here just returns the length of different samples that you're having. That's all. So get item makes use of this particular index and returns the sample associated with that particular index. That's the functionality, right? So now you are going to retrieve path and label from the given samples data based on the index that you have supplied here. That's all. So once you have path, you just need to read this particular image data and convert into actual data itself. Right? How do I do that? I simply make use of PIL module and import image. Sorry, I import image module from PIL package. Use this particular module. Just invoke open function. Use this path. I'm just trying to open that particular path or particular location or image. I convert into RGB format later because we know that it's color image, right? I convert into RGB image. So whatever data that I have, now I can reassign this to sample, right? And if self.transform is not none, the default value is none here, right? If it is not none, then probably we are looking at applying this particular transformation also to the given sample that we have defined in the previous step. And once the transformation is applied, we are reassigning that sample back to sample itself. And finally, we are going to return sample and label because that's what we want to return. So based upon a specific index, we are now making use of self.samples, that complete samples information, that complete new samples that we are having. Based upon the index, we are retrieving the corresponding path and label. We are making use of this image module to open that particular path and convert into data, right? And finally, look at applying some transformation. Preferably, I would want to apply or I would want to convert that to a tensor object. So obviously, whatever image data that I had, I need to convert that to tensor object by applying this transformation, which is now being passed as an argument while instantiating this particular class. Let me instantiate this class now by our new data, which is going to be new samples, which is a filtered data. We can also pass this particular class to index since we already have defined it. We have defined it in one of our previous steps here. We also can pass this transformation that we have spoken about. So what could be my transform object? My transform object can simply be a sequence of data pre-processing steps here. Here I'm providing a list of different pre-processing steps. So first I'm going to resize the given image data. I'm going to resize the given image data into 128 by 128. Sorry about the typo. Once we resize this, we're also going to look at converting this image data into tensor objects, this to tensor. So once it's converted to tensor object, we also can look at normalizing the data. Any deep learning model that we are creating, we always should make sure that the data is normalized. I do not want my image data to be represented in terms of in scale of 0 to 255, but rather I would want it to normalize. So I'm going to convert the complete data into the data which is represented on the scale of -1 to +1, right? So how do I do that? Transforms.normalize. Within parentheses, I'm going to provide the mean value and also the standard deviation value. I'm going to provide the mean and standard deviation values as 0.5 and 0.5. You simply can substitute these values in this formula that I'm writing here. So mean here is 0.5, standard deviation is 0.5 that I have written. X value that you already have. Your complete image data is on the scale of 0 to 255, right? The X data you already have. So your X norm data can be easily obtained by using this particular formula, which typically is represented in the scale of -1 to +1. You can do the math, you can validate it. Whatever data that you are having, image data, will now be represented in terms of -1 to +1 for these values of 0.5 and 0.5. That I'm clear about. So once we have provided this transform object as well, while instantiating this class, I can simply assign this to a new object called dataset underscore object. I can display this so as to understand if this is an object or not. This is an object. I can also inspect the contents of it. That is the different attributes that I have newly defined. I have defined various attributes. If you look at it, I've defined class to index, classes, samples, targets, and transform. I can reference classes. Now the classes should comprise of only these data, only apple and potato related information. I can also look at class to index informations so that I'll have the labels associated with these different class names here. The labels are 0, 1, 2, 3, 4, 5, and 6. There are in total about 7 different classes that we are going to consider in our overall data. Cool. Let me print this so that we don't see this long list of different attributes here. Once we have done that, we can also reference a particular sample by using getItem method that we have defined here. I'll provide an index here. I'm providing an index of 1. So this here is going to get unpacked into sample and label. So obviously, whatever sample that you are having is now a tensor object, since we have done the transformation already. Since we have done the transformation here in this particular step while instantiating the class itself. So obviously, I can make use of this particular data now in order to display this given image. So how do I display this? I can import matplotlib's pyplot, matplotlib.pyplot as plt. Now obviously I can use this imshow function and provide this particular data, provide the sample data here. We're now getting an error, a type error, stating that the shape is invalid. The shape that we are currently observing is 3 by 128 by 128. So 3 here depicts the number of channels. This is the height and width of the image data. But typically when you're trying to display the image by the tensor data that you're having, you need to shuffle this or permute this. You need to have the height and width first and then the number of channels. That's the error that we are observing now. So we can simply make use of this permute method and have 1 and 2 indices first, that is height and width first, and the 0th index last, which is nothing but the number of channels that you are having. So I rerun this code. Now the image gets rendered and displayed here. That's all. Whatever image that you are currently observing, there is some distortion associated with it. That may be because of the different transformations that we have done. If we have considered the raw data as is, then there might be some more clarity on it, because we have resized larger dimensional image into 128 by 128. This is how you can expect it. Anyhow, with whatever we have learned so far as context, in the next session, we are going to understand in detail on how you can create a data loader object by making use of the dataset object that we have derived so far.